Hello everyone. Today we will learn about the concept of electric field. What is electric field? It is defined as the force per unit charge. So in mathematics you can write that electric field E is equals to force per unit charge F by Q. Q is the charge, F is the force, E is the electric field, and here force is the vector quantity and electric field also the vector quantity. Now what is the actual concept of electric field that we are going to discuss today? Suppose we have taken a charge plus Q and we are considering this charge as the source charge. This is the source charge. So what will happen due to this plus Q source charge? Surrounding this charge there must be a force, and that force must be what? It's a non-contact force, that is field. So surrounded by these charge in certain region there must be a existence of force, that is nothing but the field. Now how to check it? In order to check this, we are bringing a test charge Q0 in the field region of this plus Q charge, that is source charge. So when we are bringing a test charge Q0, look at this. Here this test charge we have considered small Q0. That means this charge must be very small with respect to this source charge. Otherwise, if we take the test charge itself a very large, then it will affect the source charge. It will disturb the configuration of the source charge. So that is why test charge should be what? Test charge should be small with respect to the source charge. So what will happen here in this context? This test charge will experience a force, and that force is, we can write that electric field is equals to F by Q0, because this charge, test charge, is experiencing force. And E vector is equals to F by Q0. Look at this. Here one condition must be imposed. This test charge Q0 always will be trains to 0. That means the value of this test charge should be very small with respect to the source charge. So this is the concept of electric field. Now look at this. Here we considered source charge is plus Q and test charge is also plus Q0. So as both the charges are like, there will be the repulsive force in between them. So the force is what? This is the repulsive force F. So look at this. If we place this test charge here, then also the force will be along this direction. Here the force is also along this direction. That means the force due to this plus Q charge, always what? Outward direction. And it is considered that, and it is proved that this is what? Uniform, and that's why we can say that the electric field direction is radially outward. Okay, radially outward. For whom? For positive charge. But if we consider a negative charge, then what will happen? If we consider a negative charge, then if there is a negative, then what will happen? The force will be what? Attractive force. So it will be what? Inward direction, radially inward. So today we have learned that field direction is radially outward for positive charge and radially inward for negative charge. And suppose we have a charge Q So due to this charge at certain distance r, the expression for electric field will be 1 by 4 pi epsilon naught q by r square. That means if distance increases, electric field also what? Decreases. Electric field decreases. Distance increases, so the effect of this charge obviously will decrease, and it varies with respect to the power of 2 of this distance r. So E is equals to, you can write k q by r square. K is the constant, 1 by 4 pi epsilon naught. This is the concept of electric field. Thank you. Bye bye.